For this next part, we want to look at using our properties of logarithms to expand each of the following logarithms. So one of the properties that we had, so if we have log of x to the 7th, one of the properties that we saw would allow us to do something with this power inside here. And what we can do with this is that we can bring this power out in front of the log. And this is going to be an important technique for solving some of these weird equations we're going to be seeing here in just a moment. So it allows us to rewrite this as 7 times the log of x. Whether you're using log or you are using natural log, so I have to do the natural log of a to the 4th power. How could I rewrite this so that I don't have powers, I don't have anything extra inside the log other than this expression? Bring the 4 out front, so you would say 4 times the natural log of a. What if I write log of the square root of y? How can I rewrite this and make this guy better so that I don't have anything inside the log except for just y? You say 1/2, where's the 1/2 coming from? So this means log of y to the 1/2. So we see these guys as the powers, and then I can bring this power out front, and I can say that this is 1/2 times the log of y. Please understand that when we talk about log or natural log, these are functions. And so the x, the a, the y, these are all the expressions that are contained inside of that logarithm. Okay? So for these, there wasn't really a whole lot that we were doing here. We're just taking these guys one at a time so you could see what you do with the power. One of the other properties that we saw with logarithms allows us to take a product that's on the inside. For example, if I say x squared a, and I can rewrite this. And the way I rewrite this is that I take this multiplication, I take this product that's on the inside, and I can rewrite this as a sum and say this is log of x squared plus the log of a. You take a product inside of log and you can separate that into two smaller logarithms. It's going to be the sum. But I'm not going to leave my answer like this because what else can I say?
Say that 2 times log of x plus log of a.
Right, so I can say 2 times log of x plus the log of a. And that's it. That is what we call expanding the logarithm. Okay, so what if I say expand log of, let's say x to the 8th over b to the 4th? What do we do in terms of expanding when we have a division, when we have a quotient inside the logarithm? How do I rewrite that? If multiplication on the inside led to addition, when you separate them, what do you think division is going to do? It's going to lead to subtraction. So we can rewrite this to say log of x to the 8th minus what you have in the denominator, so minus log of b to the 4th. And then how are you going to finish that? How are you going to finish expanding that?
Bring the exponents out in front each time.
Right, so we're going to take this 8, bring it out front, and we're going to take the 4 and do the same thing. Here's the thing. You can't do this until you've separated into the two smaller ones. If you had tried to bring the 8 out to the front or the 4 out to the front at the beginning, it would have been wrong, because it wasn't that everything inside here had a power of 8 or a power of 4. It's only once you separate them are you now allowed to say 8 times log of x minus 4 times log of b. What do you guys think? What if we do one last super duper one? Now, I think with enough practice, you can skip a few steps. So if I say the natural log of, let's do a to the fourth times the square root of x over b to the third times the fifth root of y. How many separate logarithms are you going to have once you separate this? You're going to have 4. You're going to have one for each of the factors that you have inside that logarithmic expression. So if I just had this, if I just had log of a to the fourth, what would you say?
4 ln a.
4 natural log of a. So 4 times the natural log of a. Moving on to the square root. Is that going to be a plus or a minus? What do you think? It's in the numerator.
Oh, it's a multiplication.
It's multiplication, so that's going to end up being a plus. And what's the power on x right here? It's understood to be 1/2 because of the square root, so you'd say 1/2 times the natural log of x. When you move to the factors that are in the denominator, these guys are going to have subtraction. So I see b to the third, and I would bring that power of 3 out to the front. But since it's a factor in the denominator, I'm going to say minus 3 times the natural log of b. And what would you say about the fifth root of y?
Minus 1/5 ln a.
Minus 1/5 times the natural log of y. You might say, but why is this subtraction when it was multiplication over here? It's because it's a factor in the denominator. The powers that would lead you to something in the denominator are negative powers, and that's why we have the subtraction there. So, just as a little extra up here, if I said the natural log of 1 over x to the third, this could be rewritten as natural log of x to the negative third power, which would then be translated as negative 3 times the natural log of x. So negative powers causing you to be in the denominator lead to the negative coefficients once you expand all of this.